right, here's your hint for number 8. So at the start, setting up that first work kinetic energy theorem to find that spring constant, one thing that you might miss there is remember the height is going to be all the way from the top all the way to the bottom. So they do give you the height above the platform it's dropped. So the total height is going to be that height above the platform plus that distance it compresses the spring. So don't forget about that for part A. Part B, now trying to find the location of Vmax. This one always, like, you go with your gut and you're like, oh, it's just before it hits it. No, so that's your gut talking to you. So remember, no feelings in physics kind of thing. So what you want to think about is what is the requirement for a velocity function to be maximized? You go, okay, so if the velocity has to be maximized, that means I need to take the derivative and set it equal to 0. And so I go, okay, the derivative of velocity, well, this is when the acceleration is equal to 0. Well, if the acceleration is equal to 0, that means the sum of the forces is also equal to 0. So at some point along this path as it's compressing, some point along here, mg and kx are now going to match. Because on that little distance before we reach this, mg is still larger than kx. So it is still accelerating down, just not at 9.8. Its acceleration is decreasing, but it's still in the same direction as velocity, so it's still speeding up until it reaches this point. So you need to find the point where these two are equal. Once you find that point for part C, you're going to be working back into the work kinetic energy theorem and finding the speed when it's compressed it that far. Hopefully that hint helps you. There you go.